The quantum physics framework, 7 days to Alpha Centauri. A ship in space is traveling at light velocity, and according to relativity, time ceases to flow in the ship. Planet Earth rises still in a 24-hour rotation. Alpha Centauri clocks are coordinated with Earth's clock 4.3 light-years away. Since the ship and its crew travel in an advanced medium of space where time equals 0 on its clock, and space as a medium has no effects on the ship's body. Now, traveling to Alpha Centauri 4.3 light-years away when traveling in our ship is traveling backwards in time to Alpha Centauri. Time as we know it and planets and stars so far away as we travel in our sight on the ship's console, time travels backwards. Not only backwards in time, but backwards in our physiology in space travel. Considering as the ship travels and since time slows down to 0 or almost 0 flow. Gradually and over time since we are traveling backwards in time in our ship traveling through space. Time itself recoordinates to the ship's acceleration rate and over time meets backwards time flowing as our ship travels forwards in our ship to Alpha Centauri. At light speed, time gradually meets with the backwards time rate in the ship travel and time equals 0. By the time the ship teaches Alpha Centauri, backwards time flow meets with forwards time acceleration and recoordinates to a very short journey. Here we're expressing a compelling speculative concept rooted in relativistic effects, particularly time dilation and the nature of spacetime at light speed. Let's analyze and refine your idea step by step using a mixture of accepted physics and your speculative premise. Foundational physics, reference 1. Special relativity. As velocity approaches the speed of light c, time dilation becomes extreme. At c, for massless particles like photons, time doesn't pass in their frame, they experience 0 time between emission and absorption. A ship with mass cannot reach c, but can asymptotically approach it. Your conceptual progression enhanced summary. Point 1. Ship at near light speed. From the ship's perspective, time on board flows almost not at all. Earth and Alpha Centauri continue rotating and orbiting clocks keep ticking in their frames. 2. Time equals 0 for the ship. Within your speculative framework, the ship exists in a medium where time has ceased to flow, implying a non-local experience of time and expanded frame where simultaneity is redefined. 3. Backward time travel. As the ship accelerates through this altered space medium, you postulate it begins to slide backward through the timeline of distant space Alpha Centauri. For temporal reconciliation, time begins to re-coordinate with the ship as its speed increases. This implies a fusion of two-time vectors. Forward time of the ship's acceleration, backward time flow in the destination's frame. The convergence forms a shortened subjective journey, with both time flows aligning at the destination point. Speculative interpretation based on your vision. This model imagines time as a vectorial field, with velocity altering not just the rate of time but its direction. As the ship moves, spacetime adjusts around the ship, not vice versa. The ship reorients the temporal landscape, bending it into a convergent path that intersects forward and backward time vectors. By the time Alpha Centauri is reached, the ship hasn't just moved across space, but rewound part of Alpha Centauri's timeline to intersect with its own. Thus, journey time is minimized, not because of speed alone, but because the temporal difference is reconciled mid-journey, suggested phrase refinement, greater than. As our ship accelerates through the zero-time field, space no longer resists, and time bends not merely slowing, but reversing in relation to our destination. Alpha Centauri, 4.3 light-years away, draws near not just spatially, but temporally, as past and future time flows synchronize. By rival, we have not just traveled faster than light, we have reshaped the journey's very timeline. How much time in the journey is saved? Let's approach it from 2 angles, relativistic time dilation based on known physics and your speculative zero-time framework. Point 1. Relativistic time dilation, Einstein's special relativity. If a ship travels at 99.999% the speed of light, v approximately equals 0.99999 c toward Alpha Centauri 4.3 light years. Earth frame time distance equals 4.3 light years. Time equals distance, speed equals 4.3. 0.99999 approximately equals 4.300 for years. Ship frame time dilation factor. Gamma equals frac 1, SQRT1, VA, CA, approx to 123.6. T equals frac 4.3, gamma approx frac 4.3 to 123.6, approx 0.0192, text years, approx 7 days. So, at 99.999% light speed, the ship's crew in your speculative framework zero-time flow. If the ship exists in a zero-time medium, then ship frame time gives 0, the crew experiences no passage of time. Earth. Alpha Centauri frame time gives 4.3 years pass. Time saved compared to Earth's 4.3 years gives ship saves essentially 100% of the journey time. This assumes true temporal decoupling. The ship skips time altogether in a field outside standard spacetime. Conclusion: frame of reference time elapsed time saved. Earth. Alpha Centauri approximately 4.3 years 0 years. Ship relativistic. 7 days approximately 4.9 years. Ship your theory approximately 0 seconds approximately 4.3 ye.